Hello everyone, welcome to the stream. I hope everything works. Yeah, it looks like microphone works today. For a change, I'm a little bit late. Sorry about that. Hello Henrik, hello Jumbo, hello Jordi. Today we can do several things. We can finish this project here. 160 core Supercluster. Hey Sonic! Louder! Hey Christian, thanks for the subs. Yeah, last week. Hey TMK. Hey Nishai. Off day streaming. I'm trying to keep you sharp. So, hi Alexander. So this is last time. I don't know. The last time we worked on this project, I started to solder. In between. Between those connectors with a piece of wire that we wrapped around our soldering iron, and that worked. And I continued off stream doing with all those connectors, and then I realized that the PCB is a little bit bent. Look at that curvature. We have a slight curvature, and I really don't want to bend it, because then the pins will detach again from the pads. So, I really don't want to have to recheck for cold solder joints again. All right. The only thing that's missing about this one here is the low side connection like we did here. So we just need to add 2 wires, because I don't want to control the power anymore. I think this causes just some strange effects. 0.8 millimeters. Yeah. 4-layer 0.8 millimeters. Yeah, it's quite fragile. You can easily bend it. And these here, these are also 0.8 millimeters. We have a file here, so I can get rid of the mouse bites on the bottom of those. Yikes. Breathe in those carcinogenic stuff. Fiberglass in my lungs. I think this is alright. Just don't want to stick out too much. Yeah, this is alright. And it plugs in. FR4, yeah. So we can do that. I would really love to see today the matrices light up on this, and then try to set up some sort of communication. Maybe program on this board the numbering. Hey Basil! Basil found out that we might want to switch RTS and DTR to have the right sequence, just out of coincidence. with the reset circuit. Hey Johnny. Yeah, no worries, no worries. I didn't have like a lot of time to like go into depth. Today I did a different thing, and I asked you about your expertise on that. Maybe we can discuss this as well today, because I show you something different. Let's do it here. I mean, we talked about this before. Hey, Jeroen! Welcome, and happy birthday, Max! Or happy birthday, Max? Well, how is it in Dutch? How do you say happy birthday in Dutch? I will do my best. What was that? That sounded like some screw fell off. Gefeliciteerd, Max. I don't know. Or gefeliciteerd. Gefeliciteerd. That was very budget. Yeah, we need to switch the TTS voice to Dutch, so I know how the pronunciation is. Alright, nice. Yeah, you should celebrate with your son instead of watching a stream. You can always rewatch that one. Anyways, my today's work, or David, you repeat that once again, Jordi. Jordi's helping me in TTS. Oh wait, chat is not on screen. Code. I just noticed that chat isn't on screen. Yeah. I fixed that live. Here. I just need to start the server. And then we just need to change in... Where is the chat combined? Need to change the URL, so we just add a question mark, and here we go. Chat is here. Restored. Anyways, what I did is designing a new board. Look how clean it looks. Trying a new a new chip. The I talked about last time. What's the name? Renesas chip. What's the name? Renesas. Butchersense. Okay, here we go. But I'm not. Renesas. Yeah, that's why. Renesas. Yeah, that's. Oh wait. That's not the one. Yeah, that's the chip. It supports 2 USB, even typed like USB 3 super speed or something. And this one, I know for sure that this driver for this chip is included in Windows, so no driver installation required. If we use that and connect the WCH chip to it, so we can directly connect here USB here, but I'm not sure if the bootloader supports DFU or anything to upload a firmware, or if we need to upload an initial bootloader that takes care of that. I think like bootloader works with USB but not DFU. What kind of USB then? Is it like same protocol as yours? Oh, CDC then. Yeah, but that's all right. I mean, it's even faster. CDC, has, I don't think the limit, sky is the limit, the speed of CDC. Is it? There is no like UART baud rate or anything on CDC. Yeah, UART over USB, but you don't slow down your USB. Or I know that CDC is a little bit strange because you have like a constant stream. You don't send packets or anything. Proprietary thing. Alright. That's alright with me, as long as it works. Oh wait, to program it you need to like press boot again or something? Because then we can't do it. How do we don't have anything to do that. Wait. No, yeah, there's how do you do this? Oh no, so you need to press a physical button. Endpoints, yeah. Oh no. So maybe we don't use the chip after all. Because I don't want like to reprogram it. I don't want to press a physical button. That's terrible. And we don't have like, with our reset circuit, we don't have a possibility to like put anything on the... Oh, really? Yeah, but how do we... Oh, wait! We can force it to, like... We can jump a soft reset into the bootloader. We can do that. I disassembled the bootloader with Ghidra and didn't look too closely at the USB stuff. Alright. you looked into the depths of those things. How did you get out the bootloader? How did you read it back? I thought it might be protected, or is it like, is it available like the assembly code, or you just read it with the link key? Oh yeah, actually you can just access, like you can execute the RISC-V opcode to read memory or something. Can you? Yeah. The Linky works like that. Does it? You just execute RISC-V code. Alright, that was like my question about the USB stuff. I want some means of programming it, but we might also just switch to RP 2040 or whatever at this point, because I have issues which I might need advice before we continue with the mega cluster. I might need advice so I can continue to do the other project. Like I can order boards already while we finishing this project, because that takes like 2 weeks to receive them. You can even overwrite it custom bootloader, yeah. Alright, I mean, the only thing how do we... Okay, we might need like some sort of switch or something to put it in programming mode. Maybe we should really consider using boot 0 here, putting like a button or maybe a jumper or something where you can like use a paper clip to pull it up. GPU. I don't think so. I don't think so. And how do you access the GPIO pins? What we can do we can use the second USB and use like an USB device that only toggles the boot pin. A USB switch. And you can access that to put the other one in programming mode. Anyways, yeah, this is just some thought food. Overkill, yes. But at this point, okay, so the host chip, I took a look at it. And then I figured out, okay, all the flash, and also there was like interesting, it's not an errata or something. Okay, there is like this circuit, it's meant for the bigger chip, but it should work for the smaller one. And we look at the power stuff. So there is some stuff here that's just to switch the power to the USB ports that you host. They have some overcurrent detection, and you can turn the power off and so on. And here is some fancy power regulation. And here we have a switching regulator, like a buck converter that generates 1.05 volts. And the issue that I got now is I figured everything out, even found a flash chip that would work. I used that one. Where's the errata for that? There was like some, there is even a list what kind of flash thingies. And I always used parts that you can get off LCSC, so you can just get the things assembled and be done. But there is one issue. I can tell you now. The issue with this device is wait, that's not it. That's not the data sheet. Power consumption. Here we go. Here. Do you see that? VDD 1 volt line can be, okay, one device, super speed, okay, normal speed 150 milliamps, super speed 430, that's half an amp. If you use 4 devices with super speed, 700 milliamps. Yeah, so I thought I want another chip that doesn't get as hot as the CH serial chip, but this one is same ballpark. Like gigabits, yeah, but wow. Low speed data transfer on both ports. Okay, low speed data transfer on the port. Full speed. Okay, we can do only full speed with this IC. So it will be 140 milliamps. Yeah, no, that's why I thought, all right, I'm ready to put in a buck converter on there, so we don't like burn 2 volts of power. 2 volts difference between 2.3 volts times like 500 milliamps is 1 watt of power dissipated. Hello, Privatarian. Privatarian. So that's like a lot of power that we dissipate over like a voltage regulator. So I took this thing here. I even have the part number of LCSC because I took it's a nice package. Actually, I try to stay within the specs. So wait, where is this? Is JLC? Let me find the window with the stuff. Here. Here, this is the on the bottom of the PCB we don't have that much height. I think it's 1 or 1.5 millimeter height, so we can only take footprints without any like legs or like extensive ones. So any SOT or whatever wouldn't fit. This one looks nice. The issue with that one is I have all the parts except this here. The spec is 2 amps, 3.3. Oh wait, it's microhenry. Oh, I might have looked for millihenry. That's why I didn't find it. Okay, that's rubber ducky development. Because I looked for microhenry, millihenry, and then I was. This is just another base for USB, and on this one, so what I wanted to make out of this one is a protoboard. So it would look like one of those here, and we just put everything densely on this side, and this end will be just a protoboard where you can solder stuff. And we put on some polyfuses so you won't be melting your PC with shorts, hopefully. But yeah, this would be like a base. I can just order it assembled and then make new projects, like putting a data tape on that, like cassette drive on M.2. Base for the mega. Maybe a different one which is faster, because currently we can only do serial with this first version. Yeah, that brings us to the next point. Yeah, anyway, so this would be like a proto. Maybe we can. Oh wait, no, it's not right. Wait, where do I have a resistor in? Oh no, wait, this is not right. No, wait, you're right, that's wrong. Let's fix that. Thankfully you noticed. Here. Oh yeah, it's up here. 41. 0 ohms, but this one, wait, this is feedback. Oh, 51 goes to feedback. That's wrong. Sorry. This needs to go here. This is a wrong spot. Woo! That was a close call. Aye. Here. This one. I need to move it. Move over here. Okay. Yeah, it's odd. Maybe I should put it over there as well. This is the since this is not a fixed buck converter, but like one that you set up with the feedback. This is the feedback. Polyfuse after caps. Why though? Because the caps will charge where when they're discharged, they will rush like with 2 amps. Yeah, I thought so. That might happen. Oh, come on. Okay, here we go. Okay, so let's do that. Wait. After the caps. Yeah, I want the caps to be charged slowly. But I don't want the polyfuse to be triggered by the caps. So I'm not sure. I think in the circuit we have also, no, that's just for testing purposes. I think they have here they have some test points, and I will add this one. This is just a 0 ohms for testing of the switching supply, and we have the polyfuse, which we can always what's going on? Let me remove that. Oh, come on. Stupid. Oh, you can see, huh? Okay. Looks a little bit messy. I need to clean that up. But now, low ESR. What does the X5R mean? Low ESR, we can try to find that. What is low ESR? Feedback resistor is still wrong. Okay, let me check. I will double check everything anyways, but okay, we have 68 to ground and 51 to feedback. Yes, it is. Now, here is the inductor. FB feedback. Wait. Huh? Yes, feedback. Feedback goes to the line 51 LX. Then we have 3.3 microhenry, 2 amps. Then we have 51 feedback and 68 ground. No, that looks right. Looks, oh, sorry. I think this is all right now. Unfortunately, I had only like the footprint. KiCad didn't have this one exactly. My Bluetooth for my car is cassette based. I have one of those too. Yeah, that's all right. Yeah, feedback is basically the measuring part of. It's like an switching op amp, more or less, and it's measuring. This is the, here we got the output voltage. So this is what we want, and the divider here. The goal. I don't know what it measures for. I think it might have like. It's 0.5 volts. This would be strange. But it is like it is. We can check the data sheet for that one. So I got them all here. What's the name of the part? Is yours one in piece or individual? So, okay. I have different thing. A cassette with a plug, and then I have a Bluetooth sender where you can plug in 3.5 what is it, like this audio plug, and I have one where you plug that in and it's an FM transmitter that sends like with 20 milliamps radio signal. So different things that I got with my car back then. All right, so it looks all right. 51 to L, 68 to, so 51K to feedback and 68 to ground. That should be alright. We will test this. Oh wait, what? Not right, Rota. Feedback should be tap from the center of the voltage. Oh yes. Oh yeah, you're right. Yeah. Okay. I had it correct before. It was here. Okay. Now why did I move? Okay. Anyways, this is correct now. Yeah. No. Yes, this is correct. Looks so strange. Better now, but it looks so strange. And it's backwards. Yeah, this is okay. Anyways, better now, and we can check this out. Anyways, okay. Yeah, I had problems finding maximum confusion. Yeah. I tried to find, millihenries. That's why I didn't find the right correct size. They're way too big, and 3-point dry microhenries, inductors, SMD. Okay, that's more possible. We can even go 750 milliamps just to see. Let's see. 0. Okay, we can't do that high. Or we just see what we got here. We start at 200 milliamps up to 54 amps and see what we got. I just want something that's available, that's quite common. TDK, microhenries 350. Power inductors are too big. I want a small, look at that chonker. What is that? 10 amps. This is 10 amps. So, yeah, rather not. I'm looking for something more like that. That's this size. This is 350 milliamps. I need something flatter. This is too high. So it will be hard to find anything that might work. What's the height of that? That's 5. No. Interesting. That is also too high. Some windings around that. How big is TDK? 2.5 amps? What? We have a winner. Oh, out of stock. TDK has some great. Okay, there are some things possible. We should have used. They want us to use 2 amps. Yeah, there is no way we can get 2 amps out of that. And I also don't want super speed, but we can try. We can see what happens. And let's check in stock and apply. Oh, yeah, no, they are too big. We need to check that, but I think this is too high. This one looks good. What is that? 114 milliohms. Wow. What is that? Okay, let's check. 70 milliohms. Yeah, this is 114. Wait, I will zoom out so you can see the specs. So actually we can find something maybe. But this is cool. I don't know what is the what values are important on that? Is this the DCR? What is the DCR ohms? That's okay. That's DC resistance. So this is not very efficient. The other ones don't even. Oh, 5 milliamps. Oh, look at that chonker here. Maybe we should limit that. Limit that to how many ohms? That's too many. Wait, what was 70 milli? So we can just take these here. Yeah, they're all too big. Too big. And the ones that are not too big are not available. We can check that one. What is the size? 1.8. Okay. M.2. Let's check the specs. What we can put on the bottom, but I think it's only 1 or 1.5 millimeters. It's too high. So this would be out of spec, and I want to stay within spec. Actually, we don't need 2 amps. I can go just lower to. We are not at the USB 3. So wait, what's the data sheet? Sorry, I'm jumping around here. We can't do super speed anyways. So the highest we will do 4 ports, 150 milliamps. Yeah, we don't need like 700 milliamps actually. Super speed. I only must know that we need more of that. On that rack, what does the rack mean? Rack. That's interesting. SS hubs, super speed hubs and devices. No device power consumption. Yeah, that's all right. Yeah. Yeah, I just used the 1 volt marker because there was no specific. I don't know if we can change that. Oh, we can change that. We can change that to that marker and put it also here. And I forgot to put some caps here. Oops. Sorry. I think I need some more caps like that here as well. But we have caps. We have the polyfuse, maybe 100N would be enough there. Okay. Just to have it close to it. What is datasheet? The datasheet is meant to build like a graphics card or something. That's like there's no way there is no way we can fit all those pieces here. Like look at that. What is this? This is like a PCI Express extension card. There's no way you can put this all like a gazillion caps. Look at that. 10N, 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 10N. What? Like a an array grid of capacitors. What does that mean? 3.3 volt dual. No clue. Yeah, this is like the bigger chip. The 201 is the bigger one. 202 doesn't even have that many. Yeah, caps, but do I need like do I need like more than just 100N cap? Wait, there is a 10N and then 100N. I'm using the O2, but there is no specific circuit for the 2 at the end. The 2 has fewer pins, so let me show it. Wait. Here we have only VDD 3.3, a VDD 3.3, VDD 3.3. There's I think two different 3.3, maybe like per bank or something. A VDD. Okay, there are some. It's strange that the symbol doesn't have that many. Are they like connected internally? Damn. Do I need like 10N and 100N for each of the power pins? Really? Then I might extend it even more. Okay, so let's finish up. And some fewer 100N. Sup, dudes and dudettes. Hey, Dodge. Yeah, there's like on each side there is one, and I think I will do each cap like 100N, 10N on each side here. So we would be fine. So we have like 6 caps on each side. Yeah, let me do that. AVDD 3.3, maybe only 100N, I don't know. That's the communication. It is only here though. No, we have 1, 2. Okay, 2. It's like 8 caps. Yeah, whatever. just leave them away. They just want to be on the safe side. If you use crappy caps or whatever, I think like you don't need all of them. Hey Johnny, are you here all the time already? Did I greet you already? Anyways, hello. The PPON pins. PPON. But how do you abuse those? Because overcurrent detection, it turns off. Is this like? Did you check if you can use them, like control them from the firmware, or is it like auto detect, and then whenever overcurrent is detected, it will automatically turn off USB power? I didn't check, but I suppose it was like that. Control signal. The timing of blah assertion. Asserted immediately after PCI Express reset. Oh, you know what we can do? Okay, there's not much information about those pins. We have something else. We have also the SB bus, or what is it? Resets. Can we use something from here? Okay, config, that's alright. Clock LED, nah, that's the HDD LED. You can make it blink even, if you like. Yeah. Yeah, but oh wait, no, yeah, let's leave it like that. I mean, we can somehow do a soft reset into a bootloader that's pre-programmed or whatever. It's always like you have to die one death. I'm wondering if there is on the RP2040 you also need to press like a boot pin or a programmer pin or whatever. I mean button. There is a second power supply race node. Oh, Terran! Please! No! Yeah, it will, but if you look closely at this here, here. I add a regex for the blocked address. Oh, what? Christian, what? So, yeah, this is the one. They only mention it because of so many caps. All right. Oh yeah. Look at that. They have like a switch for the supply of the 3.3 of the. All right. Here they switch on the supply from the other supply. So you have like ATX power. They convert 5 volts to 3.3 volts, and they turn on 3.3 volts to continue generating, stepping even further down to 1.05. So they have like a stage here because you're not supplied with 3.3 volts, maybe, I don't know, not sure. They expect only this power here somehow. Or whatever, that's why they do it in steps, but we don't need to. We get only 3.3 volts supplied, so requiring anything higher than that would be difficult, especially with the USB part here. Okay, manual 3.7, which one is it? This is the... Ah. How do I guarantee that? This is stupid. I hate this chip already. So many demands. It's a snowflake. I just want to use it. Not write like a master thesis on a chip. Not atypical to have array management. Yeah, it's not typical for me. Look at the soft start of the RT. Okay, let's see. Do I have linked? I need to find that chip. This is. Let's take a look at the. This will be difficult if we can't. Okay, here we go. Datasheet. I mean, they use that. "25 microseconds. Wait. Yeah, it's fast. I don't know what that's the difference. There is a soft start graph. Where is it? Here. Yeah, it's less than 1 millisecond. Soft start, inrush current. Oh, 2.5 milliseconds. Ui. V in. That's like 5 milliseconds. Something like that. And what was the requirement? 100 milliseconds? Yeah. That's good enough. I think as long why do we need to turn off that quickly? So we can't have too many caps. Yeah, I think also. If we put in too many caps at the rail, it might take too long to turn off the 1 volt rail. So actually, it's not good. It's not good to have too many caps there. All right. I still have something on my stack here, and that's finding the right. Yeah. Where is it? The inductors. I need to finish the inductor search here. Oh yeah. Let me check. The specification for M card platform connect. Okay. Specification. This will be expensive. The BOM cost for one of those boards is already like $10. The BOM cost alone. So like the Protoboard, if you want to sell it, it has to go for like $30 at least. And the PCBs are also pricey. I don't know if this is like a product at the end, but it will be certainly something to have fun with. Okay, here. Type M. Oh. Do you see that? 1.35 millimeters. Yeah, not happening. That's too big. Alright, so let's try the lower current ratings. Wait, what is this? These are like only the huge ones. Oh no, because of them. Oh no. We have too many filters now. Shoot. Wait. There's some filter is here. Just the 3.3 microhenry. Let me remove that. Okay. Smart filtering. Only in stock. Okay, here. 3.3 millihenry, microhenry, here we go. Okay, we want like 0402 SMD. Yeah, I don't know what the foot. Whoa, look at that. They are tiny. We want some. Three. Isn't that off? I mean, I can take it. It's off a little bit. Oh, by 1%. I mean, even the 3.4 is within like spec. It won't be like the most efficient one, but anyways, if we pick like plus minus 10%, then okay, and we want something that's less. Do that. Remaining, and then in stock. Oh! Still a few remaining, but they're all the wrong size. Oh, you found something? Let me check. Bloop. Oh yeah, that's already that's in stock still. Oh wow, that looks good. Wait, huh? Why didn't it list before? What's the inner resistance? Yeah, that's right, milliohms. What's the size? Did you check? See? Okay. Here, spec. We have 2 millimeters is too high. Yeah, we need to check if it's the 5, if it's the 12 at the end. Wait, where is it? The 12. Yes, it is. Yes, that fits. We have a winner. How did you find this? Did this list? I just need to scroll down and it then show up at some point. No, it doesn't show up. How did you find this? This is strange. Alright, so we have a winner. That's cool. I use that. I just need to set the footprint and store the part, the LCSC part number. And then we have a new board almost. I will lay this out later. Yeah, you watched too much of EV block. Yeah, it was probably because I was filtering something where the value was missing in the table. So it's too restrictive. Okay, that is that one. And I will use... This is crazy. This is the perfect thing. We can copy the part number, so this will be I don't know. Let's do that, and let's copy the data sheet, and let's set up the specs here correctly. Huh? Why? Awkward thing, it hides 2.9. There's plenty of small height if you filter for package and... Oh, interesting! Is there like a cheaper one? I mean, 11 cents is not that expensive. Strange. So package is... Now I need to change that finally. That will be 1210. You're complaining about... No, I'm not complaining about that. I mean, it's China. I expect it to be 0.1 cent. Okay. Let's fix up. That's certainly not the right footprint for the inductor. I need to save it first and then take the changes. Boop. Here we go. Yeah, quantity costs less. There is one warning. Hey Caspar! Grab a tea, sit down and enjoy the show. we just found out that I messed up big time. Without chat, I don't know if I would be able to make anything. Like, I would need like more revisions than that. Okay, so what is this chip? Oh wait, that's our QFN. Our Q. This is the other QFN. So this is the MCU. This is the USB. Late? I start at 8. Oh, liberation. Oh. Yeah, that's true. That's true. There is a diode. I hate it already. I don't know. Oh, there is one thing maybe that you can help me with. I don't want to do a layout this thing, because if you look closely, I mean, I can look at the caps. If I don't do like 0402, yeah, I will switch that for 0402. So we can put this somewhere here. We can, interestingly, they require 80 ohms. I put, no, 90 ohm differential for the differential pairs. Needs like 90 ohms resistance. You will be for sure watching a stream if you tune in on Wednesday as always. But there is always the option for Friday and Monday streams. Whenever there is project pressure, in that case we have a little bit of project pressure. Alright, so the idea is now we can lay this out. Okay, I can add something here. Let's add just some connector pin, or like what is it, 8. Let's do 8 pins. 8 pins. Let's assign this. I hope they fit. Wait, 2, 4. Yeah, that should fit one width of. No, not any day. It's Monday, Friday. I would never stream on Thursday unless a Wednesday stream is not happening or something. So okay, where is this? 1 times 8 here. Okay, I assigned that. That's alright, that's alright. Can we clone this? Let's clone that. Let's clone it like that, okay? Then let's assume we put everything like the MCU, the flash, the power regulation, the caps in a smaller form factor, in some way or form here, like that. There's some more caps. Maybe the programming pin header on the bottom here. And then we have something like that. Here. That, and maybe some mounting holes. Yeah, that's all right. That's all right, that's all right. Maybe even more. Let's do more. Look at that. We can do even more. Let's do more. More. Okay. Ah. Like that. And then you can just order this assembled and put whatever you like with through hole on that. We will just put like power and so on, put it there somewhere, maybe one header here, and maybe strips or something. What do you think? Isn't that cool? It will be very delicate because this will bend easily. It's 2.4. What? 2.2 millimeters? Or 2.54? No, it's 2.54. Sorry. I'm confused of the. Yeah, it's the right one. 2.54. Yeah. Here we go. So, and what happens after that? I mean, I can do a version where I just put LEDs on this side, the complete thing. We won't have as much dissipation, heat dissipation as with the other boards, since we are not burning like extra 2 volts on the LDO or something, but I could put an LDO instead here. Maybe put multiple LDOs and spread it apart so we distribute the heat a little bit more evenly. But I don't want oscillations there. Anyways, what we can then do is we can create better audio. Nice. Speaking of better audio, let's take a look at this device. Okay, so.
Hallo? Bitluni?
It's not like the super micro cassettes or whatever. It's micro cassettes, but it's not the small Sony digital ones. They're unobtained. Yeah, that's not. I got. You know how much I paid for this one? This is a little bit roughed up. Like, I mean, it's a little bit bent. Yeah. Yeah, that's the thing. This thing is tiny. Yeah, it's too expensive. I paid $50 for this one, and usually you pay more. I don't know. I was lucky, I believe, because also it's a little bit. Yeah. Very poor, very poor. Like the audio is terrible. But it runs of one AAA battery. So we will certainly get enough power of M.2 to make this a dead drive. Like look at this. we can either keep the case. This is my counter to SSDs. We have exchangeable NVMe SSDs with tapes that you can switch. I have more tapes. I bought several tapes. So we can store data like the C64 on the C64 games. But look at this. I took a close non-released LT. But actually make it red. Yeah, and I would speak that, and then a secretary would type down what I memorized here, or my thoughts. Okay, let's take a look at the device, because I found this really interesting. It didn't came with a manual. It came with a case, like a leather. I feel really bad to disassemble it and take it apart and yeah. No, it will be random access. We can make it random access. So really don't. Yeah, basically, Luniland backup device. Yeah, we will be able to store like one diskette, 100% analog. Yes, it is. If you don't mind, now the people are going crazy here. We love that idea. This is perfect. I mean, yeah, random access if you don't mind to wait. But okay, if we press rewind like that, it automatically stops at the end. So and there is a digital display even. So we can track the seconds. Forward. Wait. Okay, I can, with 2 taps, I can go forward, you can see rotating it here. And we get tracked, like seconds tracked on there. So we can basically calculate a position for the next sector and then play, read out the data of and we have like, let's say, an initial signal that indicates a new sector, then the data is read out. If it's the wrong sector number, we can rewind or C60 tape. Let me do that, rewind. It's interesting, it even tells with the spots like press once for rewind. This is forward. It's forward. So we can attach maybe to the display driver and read out that, the state. Then I looked for FSK. Yeah, I will start with something very simple and then maybe do Quam 16 or something. Or like multi-frequency modulation. We have enough power to decode like some DFT or oh god. Oh yeah, cool features. I bought this because it's tiny. It fits on the footprint of an 80mm M.2. Then it has digital buttons. There is not mechanical. The only mechanical thing is to open the cassette tray. Then, interesting thing that I found now that I didn't know, I didn't research it, I just bought it. It has a remote connector. Then, okay, reverse, I don't know what that's for. VCA, I don't know either. Probably you can power it somehow a different way and you get better quality with double speed. So if I rewind and play it now, you can get better resolution like. Resistor ladder. Yeah, we can find out. We can find out. So there is like double speed and single speed. Yeah, I will do a Turing machine. Oh yeah, let's do a Turing machine that can store data on type and calculate it. A Fibonacci sequence on a Turing tape machine, M.2 Turing tape machine. Oh, do I dox myself? Yeah, the possibilities are poor mechanism. Yeah. Now, look at this. No, you don't need perfect servo positioning because okay, we need CAD software. So pointless. The possibilities are pointless. No, it's entertainment. Yeah. Yeah, 30 minutes per side, I think. Because I show you something. This is even more crazy. Okay, so we can just do something like that. We have like a carrier frequency, like PAL signals or NTSC. We have like a frequency. Whoop. And let's say this is like 1 kilohertz. And this is then also we get our phase corrected here, and then we have like a data block encoded in different frequencies. Like let's do this is only symbolic, so we can do different frequencies that are like prime numbers or whatever, and then we can do a encoding phase encoding and whatnot encoding. Or wait, the COM 16 is like that. Yeah, something like that. Encoding, and then you have like, this is only one frequency, and you can do this for multiple frequencies. This is like the phase, and is this the phase? Or maybe this is the phase, and this is the frequency. What's the symbol for frequency usually? I don't know. Theta. we only take Arabic F. Yeah, okay. So we have phase and P and F or whatever. And whenever we can do like this data, this synchronization here. This is the synchronization block. like with video signals per line. You have like the sync block, and then we can do just, this is data block, like an index 12, data block 12, and then followed by the data. I don't want to mess around here. Let me put this somewhere down there, or maybe, yeah. So we have the sync, and then we have ID or index. Okay, so this is sync. It's quite a lot of overhead, and then we have data. Something like that. And then this is just a block, and we can leave some space in silence. And then we can just store every second, since we have a digital indicator on there, we can store like every second just one data block. We have 30 minutes, that's a lot of data that we can store there. And then if we like seek something, we'll just end up somewhere in the middle. We will wait for the 1 kilohertz sync signal, read the ID, and then see, okay, we are too far, hey, electro checker. Six bits per second anyways with this type of, yeah, probably. We will find out. This is the best part about this. We can just experiment and find out. How do I show this? I don't know if you can see on camera. Z80. Loading schemes from Z80 Spectrum. Here, Basil. Basil the mouse detective. Yeah, certainly we can. You vote +1, Casper? Yes! It has something to do with audio and analog tech, old tech. Okay, let me show something curious about this device, because I don't know all the features. It only arrived today, and I was still designing the software. How do I open it? Okay, there are two heads, like one here. You can't see. It's not. How do I? You can't look inside. Okay, here is one head on this side, and there is a second head on this side. And they are basically shifted. They are shifted, and I think this thing can read. You don't like. They don't move the head like an audio device where you have forward swap the direction of the tape. It just has two different heads, and I'm curious if we would replace all the electronics and only use like the heads and so on, if we can read even like the both sides of the tape at the same time simultaneously. That could work. But I was really surprised that they squeezed in like even two heads in there. Maybe let's take it apart. Interesting also is, look at that, it's always on. There is no off switch. I don't know, I can put it in hold, but the display is always on. I think the battery lasts forever. Playback has output for both directions. Let's open it up and see for ourselves. I will be very gentle. I know the retro people will kill me, but You could have bought it also for $50 if you liked it so much. And the Olympus, the Sony are really super expensive. They cost like $200, and this one was 50. So still quite pricey for like this bad quality. Okay, we can maybe open it up. I don't want, we need to be gentle, and I need to put it back together. Oh, no other controls? Okay. Yeah, well then we will just, that's why I took the digital buttons here. That's true. I hope it doesn't like fall apart instantly when I open it. If yes, I will have everything on camera here. Oh wait, these are shorter. I need to be careful. The shorter ones are on the side of the buttons. Yeah, they are very short here. So probably the panel isn't that deep here before the mechanics starts. I can't open it easily. This feels like this feels wrong already. Also, this thing is glued on. No. Remove the cassette. The cassette is not in there. We can also there's like some sticky stuff on there. I think this might be even just glued on here. This cover aluminum. I might just want to heat this up before I take it apart. Look at this. I think I have like some. I will remove. Nah, this glue that squeezes out, and I have some special glue for gluing in like smartphones, special tape, because I think we might need to remove that part, and not sure if there is like. I don't want to break it. Oh, it comes off a little bit here. Ah! Uh-oh. What about this part here? This plastic. Not sure about that plastic. This screw doesn't come out. Oh, now it's locked in. Oh, it's actually longer. So, okay, the short one is on this side from the display. Now it comes off. And doesn't come off here. Here. Oh, it came off. Nice. Okay. Without destroying anything. Oh, I lost already the buttons. Wait, where are the buttons? I lost the buttons already. 2 of the buttons are gone. Where are they? Huh? Where did they go? Gone. I just roll with maybe. Oh, they're down the mechanics. Oh no, I lost them. Yeah. One fell down on the floor. Just must make sure that I don't roll over it. Damn, where's this button? Ah, here we go. Okay, all the buttons are here. Found it. So I just wanted to show you that there are like two heads in here. There is this protective shield. I would love to take off the tray, but this is not a screw. So there is the spring. We could release the spring and so if we remove that tray, yeah. Okay, this is screwed in. So what we can try is putting it in while the tray is open. No, it doesn't work. I don't want to take it apart completely. But it's easy because you just bend this over and remove that part. Okay. Here. I just recorded it before I break it. Here, you can remove that. I just need to take care that the spring doesn't fall off. Oh, here we go. So, spring. Oh, we can leave the spring there. There is a long pin where it's mounted. Does it even focus? Here. Okay. So, this is how it looks like. Oh, interesting. Look at that. That whole upper thing moves. Now it's locked up there. And we... how does it release again? We need to release it somehow. I don't know where it's locked. When the tray closes... Okay, the tray closes. I think the mechanism is triggered somewhere here. I just want it to be active while we... Where is it locked? Ah, this presses down. Nope. Any ideas? You can see probably, huh? This is the mechanism. Oh! All right. Okay, I found it. Okay. Yeah, I will re-record this anyway. So we can put this in now. Bloop. And then there is the mechanism. Wait. Here we go. Okay. So we can leave it open like this. We set up a few millimeters. Footprint within, at least size-wise, it's within M.2 specs. Let's show how it works. Oh, the heads are not even lowered. This is interesting. Okay, so let's play. I think play was here. Play. Wait, it doesn't play. Doesn't do anything. It didn't detect the cards. So probably it has like, I mean, didn't detect the tape. So probably it thinks there is, the tray isn't closed or something. Yeah, this is like, I'm really positive that since a AAA cell is like 1 amp or something, maximum 2 amps, we can certainly power it from M.2. Okay, it somehow didn't detect the tape. So if I release it, it's closed. Can we put the button in? Oh wait, I have hold on. Ah, hold was on. Sorry. Here we go. Oh, error. I destroyed it. Uh-oh. Error state. Oh no. Yeah, it's dead, Jim. I destroyed it. Okay. Let me remove the battery. But also the mechanism doesn't release. It's... Oh. Interesting. I think it's locked up. I think it won't work unless... Oh, it released. Okay, forward. Let's try to play. No. It doesn't like it. Yeah. Okay, I think there is some bad detection, but I need to release. Hey, Mogget or Mog 3T. I don't know. I just need to release the mechanism so I can open it. Okay, like that. Doesn't, okay, wait. Can't. me remove the card, and I hope I didn't break anything. Let's assemble it again and then see what happens. Strangely, I can't feel the springiness here. I hope this had to do... Huh? Wait. Somehow, something's off here, because the release mechanism doesn't pull back anymore. Okay, let's assemble it, and or let me add the tray again and see if we can, if something changes there. So this goes here. As long nothing physically broke in there, we will be fine. So where does the spring go? The spring goes there. I need tweezers. Okay, spring is on. Hey, Artem. Oh. Oh. Wait a second. There are contacts. This is interesting. Down there are some contacts. And they are, I think, detecting if the tray is closed or something. Maybe. Ah. This one bends too far forward. Maybe I bent it or I broke it already. Here we go. Hoppa. Oh no. Spring fell off again. Okay, I need to make sure that the contact is behind that. Where's the hole? Here we go. Okay. Record of the... It's not 70s. It's a modern dead drive. Data... Oh no, it's again! Damn it, this stupid contact. Why is it always... Here we go. Okay. But this isn't closing because the mechanic is locked. Somehow it blocked. Okay. Now it's working again. Better than ever. Let's put in the battery and try again if it works. I hope it works. Oh. So we might need to keep the tray, but we can remove that. We can take a look at that things. Uh-oh. 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 Oh no. It's in error state. Yeah. Something's off. Oh no. Okay, I sit down. I shouldn't have taken it apart. And it also locked up somehow. But why? Why did it lock up? What happens here? Oh wait, the heads are down. Flip to other side. Do you think so? Oh yeah, it was end of tape. It was just end of tape. Can't be. And where's my recording from before? Looked like it was an error. Oh, wait. Huh? It rewinds. No, it forwards. Huh? Wait, a reverse on. Let's record something. Hello, this is bitluni and chat. Chat, say something. Say. I'm recording from the headphone. Something. All right. Here we go. Now let's stop it. Okay, there was something, but the quality is so bad. Alright, okay, so this is our device. I will just assemble it again, and then we are good. The buttons, I don't know, they're so delicate. I will put them in here. Yeah, I hope it's only the amp of this small speaker and the preamp of the shitty electret microphone in there, and that we will be able to actually use better quality with our built-in DAC and direct. Oh, fuck. Okay. I need to do it like that. Yeah, but I like the size, I like the tag, and I like that it's all integrated and we can interface it. I hope I don't need some level shifting here. Oh yeah, yeah, we can try a microphone input. Yeah. Oh wait. Oh, this is awkward because the microphone here, this plastic part, is so. Last button. Ah! Here we go. Okay. Okay. So it's assembled. Wait, there is one longer screw. Where does this go? That doesn't feel like it's the right screw in the right spot. I hope I don't screw it by using the wrong. There are like three different lengths of. Yeah, that doesn't feel right. Oh, now it feels right. Okay. Oh! It puts the tray in place. Alright, here we go. It still opens. Yeah, this. I guess they had this, since this is made in Japan. I guess they had some like Japanese front plate here that just glued it in. Nice. Yeah, let's try a microphone, but I think this isn't like. Oh, that's like some smaller microphone thingies. Wait, do I have a plug like this? Might have something. Might have some, but I'm not sure. I have certainly a remote, but I don't know if that will work. Yeah, I don't think I will have this size. We will just extend it by Bluetooth. Still running. Huh? It's standard, but it's the smaller standard that I don't have. Look at that. You can't plug in any. You see that? And that's Japan, and not. I have. Where's my bag? My photo bag. I might have an adapter or something. I don't think I have actually an adapter. What's the 2.5 millimeter? Yeah, it might be. Let me check it. I should have something. I mean, like photo cameras use remotes like that. Some crappy adapters. I might have them here. I don't see anything. Also, where is my photo bag? Cell phone headsets, yeah. Not anymore, unfortunately. But oh wait, maybe in my drawer with the phone stuff is. There are a few adapters, but no 2.5 millimeter. Only bigger sizes here. Yeah, anyways. I might find one of those, but I will just attach some wires directly to. Idea would be directly attach them to the buttons so I can control the complete device, and also there must be a chip for this display, and that will have some segments activated, so we can actually read out all the segments, maybe. I hope we don't need like level shifting. It runs off 1.5 volts, which is under any threshold or whatever. So I hope it's like boosting up to 5 volts or something. But in that case, we would need a level shifter anyways. Alternate world, yeah. AC coupling. Yeah, but not for the buttons, the button controls and so on. I guess they could be pulled low. If they're high and they are pulled low, the buttons, then we can do that. But the display, I don't know. Maybe we can't read that. That would be nice to have, like, read the mode of what's happening in there. Bunch of optocouplers, that's a good idea, actually. Good idea. Infrared optocouplers should work at 1 volts. 1.5 volts. Infrared optocoupler. Opto insulator. Oh wait, we already streamed for 2 hours. What? SPI didn't exist. Oh. Supply voltage 15 to what? Okay, that's not the one that I... Let me check. Gate drive optocouplers. Gate drive. Opto insulators. solid state relays, logic output opto insulators. Okay, so we can check. Oh, you think there is no, it's just all integrated in one IC? Might be. Zero? What is... Eh? It says... if you can find the service manual for this, or we can check. I see we are only doing like a fun stream today. Not coding for our Supercluster. What did I do again? What did I press? We should have looked at the... Should we open the backside? Okay, custom ASIC. Okay, let's see. Let's find out. Model number is here. Pearl Coder L400 micro cassette recorder, Olympus. It's in the main state. Yeah, back then in the 80s, like full state machine on there. Oh, again, different lengths. We have two short ones. How do I open that? That's just held back by the... Oh, wow. It opened. Oh, it's completely flat. Yeah, that's why it's crappy quality. Look at the speaker in there. '92. It's completely flat flex. DC motor. Oh wow. This is dangerous. He can destroy this easily. Okay, let's put in the battery and destroy it and measure some voltages. Oh, we lost another button. We can check voltages. Oh, I love this. I went totally in the rabbit hole with this RetroTech, and I also bought an MD, NetMD recorder. So, but that wasn't shipped yet. Stupid eBay seller, but I can't complain because I didn't pay much. I paid only $100, which is what? For regreasing, it would have to be desoldered. What? Like in yours? You mean like that one here? But that's the interface. This is interesting because these are the interface buttons. We can just attach to that. Okay, I will record this. So we have the, I think this is the interface panel for the buttons. Let me measure. I don't want to short things, but $1.38. Oh shoot. $1.38. There is. It's actually running on 1.5 volts. Oh no. This is crazy. And also I don't like, I hope that the main PCB wouldn't wrap around the battery compartment. I hope there is like a correct pin distance. Yeah, that's all right. We can interface that. Yeah. What? Frequency response 400. Oh, does it say like that? Did you find the manual? Z80, or is it like specs for the tapes? There are a lot of frequencies in between. What is this cute device and why it's not Supercluster? Also, hello and greetings to the chat. Yeah, there is the Supercluster. But Supercluster, I think we will continue with Supercluster since we are in the rabbit hole of this cute recording device. So Dave, do you like this device? It's running now back. This is our. Yes, this will be an M.2 cassette storage. Spoiling things here. I'm spoiling too much. It's a secret. Yeah, I got it quite cheap for $50, which is really untypical. Even with the original. Look at this. Milliwatt power, that is even more than DEX. Class AB amps. I forgot the buttons. Okay, let me put in the sliders back because I forgot those. And this switch is in main state. So was the long one in this corner? I hope so. And the short ones were on the other side, huh? Okay, I didn't see the chip. I didn't want to like rip the thing apart, the whole flat flags. We need to keep it alive as long as. Hello, it says hello again. Pink watch project? Oh wait, that's forward. Oh, this button is stiff. I think I assembled it wrong.
Dieses Gerät is weird.
Okay, these are my recordings. All right, that was that review of this cute device. I feel really bad to disassemble it. I tried to be non-destructive with it. So please excuse this beauty thing. Yourself, thank you for the follow. What? That was little distraction. Yeah, a little distraction here. What we wanted to do is this here, programming this, but it's so late again. Let's continue on Wednesday. Or do you have something in mind that we can fill like 40 minutes with? Because I feel tired. Too tired to make great leaps with the code of the Supercluster. Let's wear out the connectors. If this works, I eat my head. I eat my shoes. Look at these small cassettes. This is so cool. They open sideways. So cool. They were quite expensive even. I think I buy €4 for one of those. Got 4, so we can store a certain amount of data on there. Hey, nice. So welcome to the team, yourself. Or is it yourself, 487? Is this the coprocessor for the 486? Electronics madness, yeah. So here for the people who just joined, we had a discussion how to store data. Yeah, we can have some like indicator. Casper, you look faster. So how to store data. I hope this was clear. And we are trying a new chip. A new chip with a lot of buck step-down converter, new USB host, and oh yeah, there is no way to set B0. We need to find a way to set B0 somehow. Anyways, oh! Maybe we can use the low profile side button on the M.2 board. That would be silly. I used side buttons before on ZX micro drive. Wait, where is the GPIO expander? GPIO expander PCA 9536. Okay, let's check that. What is PCA? Yeah, good night, Jody. Oh yeah, and by the way, this is like what we will end up with maybe. So an M.2 with a microcontroller on the back, a fast USB interface to the microcontroller, and some perf board on there, so you can make your own project. And I will use the tape drive will use with this board. So I will order this, and then maybe some more mounting holes for 3D printed brackets or whatever. And this should be like a prototype thing. And if that works nicely, I will just let it manufacture in China and ship to those people without tariffs. I think electronics are not tariffed anymore. Only 10% or something in US. Is that true? I will declare it as a Apple computer. What is this data sheet? Let's take a look here. I/O expander, SM bus, yeah. Oh, that's not bad. But how do we access SM bus? I mean, from Linux, that's easy. From Windows, not so much. I don't know what way to control it. There's probably just one address that you need to I mean, this is I2C, so you have like one address that you... Okay. You have one address. Oh, they are drivers? USB SM bus. Oh! Wait, Arthur! Yeah, put that one to the second USB thing, because we have two USBs. But then, what do we do with that? I would do like a USB I/O expander. We can do, we can access certain USB parts from the browser. If we use, because I always want to end up using the browser. Isn't there a PCI Express USB plus SM bus? Yes, there is. Probably there is. But this is like USB to I2C and SPI. Yeah, I can just attach an CH32 035 with USB, which will toggle the pins. Like a little coprocessor. CH. Okay, let's check 347. Yeah, the drivers, installing the drivers. I know the drivers will probably be included at some point, but what do we have? Oh yeah, that's the, yeah. To UART, JTAG. Oh, it's a typical USB. I mean, I have a gazillion of USB CH serial USB to serial chips. There might be. We just need like an I/O thing. Wait! Oh. Basil, we're back in the game, I tell you. We will just use USB to UART and then use the lowest possible spec, like the default ones that we always use, like with the like this here 340T, this one, and then we just use DTR and RTS. Sub 8, yeah. Oh, but the sub 8 doesn't have the PLL, I believe. Aren't they higher than 1.3 millimeters? I would need like, yeah, something like S sub. Shrink small outline package, miniatures M sub 10. Miniature package. Body size. Yeah, I think we need this then. M sub 10. That's that size. E and X. Oh no, there's no DTR and RTS. RTS is there, but DTR. Oh no. I'm sure there are many SSDs outside the spec. Yeah. But if I make a tape drive, the bottom of the SSD is inside the spec. The top might be a little bit off. Body size, so this is the height. I mean the sub 16 is alright, 150. That's a little bit, I mean 20 micron. Where is it? T now. Oh, there! Yes! That's good. Yeah, we can take that one. That's cool. Actually, it's not that bad. So we can just add the serial chip and connect it to the, just like we did before. So we have the USB, we have the built-in programming mode, and we have to have this reset circuit again. Damn it. Do we have more control over that? I'm not sure. So interesting would be like to have the serial to this chip, so we don't need to do CDC and can use the USB for something else if we don't use like a multi-device mode or whatever, hub. How do you call that? When you have more modalities on one USB. That would be a fallback thing. But then we have to get the reset circuit right again. Basically, we could use it. No, it's not a hub. I mean like composite, yeah, composite device. Yes, I want the possibility first to talk faster, so higher speed CDC, basically infinite speed. No, what is it? 5 megabits per second. And then I want the drivers to be included with Windows. The CH340 are included. I think the other ones are not. So actually we could use your programmer, your web ISP, to program the device, or we could use like USB mode for that if we like. And a special combination of both if we use like the reset and the boot pins with RTS, DTR or whatever. I think I will keep that idea. CH340X, there is it. I will keep that idea in mind here. Ah! What is this V3? What does that mean? Do we have a data sheet? There is a data sheet. Yeah, this is the same data sheet. Yeah, for in-app cons, but we can still use like the serial at the same time, just with the serial port. It's just the same, isn't it? I mean, we can still use like the serial and USB at the same time with this chip. Programming it if we want to, but also communicating, like debugging stuff. If you imagine you develop like USB stuff, like a sound card or whatever, it will be hard to debug it since you can't attach easily. You have like, I mean, there are pads for, but they don't have like TX and RX. So it would be cool to have something which you can't mess up, and the serial you can't mess up. And then you can use that for programming, debug communication, or like transfer of stuff. Yeah, something like that. And then you have additionally the full speed USB CDC or MIDI device or whatever. Oh, wait a second. I just realized there is a simple interface for controlling. Yes, USB MIDI. We can control it from the browser, and it's a wider support than web serial. Wait a second. Web MIDI API. So, my little keyboards, let me grab something. People, we are dreamers. We are dreamers. Okay, so. You don't know that there is a MIDI API? Of course there is. I used it before to control devices like this, Launchpad. And there is one thing about this. Like you have a specific program or a channel where you can send MIDI data to this device and control the LEDs here. They are like green and red, I think. So you can mix them. And basically each node is a different button here. So the same way we could set like LED pixels with web MIDI. In that case, isn't that cool? This will be amazing. Especially there are programs already that probably can do that. There are different launch pads that also support RGB. If you have something. Let me check support. Look at that support, peeps. Look at that support. MIDI request, MIDI access. We have Opera, Firefox, Chrome on Android, Opera on Android, Samsung Internet, WebView. So that's wider support. Headers permission policy MIDI. Only Firefox doesn't. It's partially supported. Request MIDI access. MIDI input output. Yeah. Anyways, much better support than Web USB. Yes, Web USB also is hard limited. I don't know. I know that I didn't need permissions before. If you select the device, just like Web Serial. Yeah, Web Serial. Web Serial has only like 2 browsers in the end, like Edge. All WebKit browsers and Chromium-based browsers have Web Serial. So I know that I used it with Firefox, and I even made like a sequence for the web browser. I don't know where it is. Maybe we can find it somewhere. So you could basically record notes and then play them individually, like a Launchpad. So I made this for this device already. So we have an idea. We should write it down, because this is oh no, yes, okay, here we go. Let me check to not dox anything here. Okay, that was our to-do list from last time. Now we have second USB CH340 to serial and RTS DTR reset. Set. Second. I hope we can control it better than with the other chip. Then we can do web USB, not the web USB, web MIDI to nodes equals let's. I think there are different, not different Is this channels? Yeah. Channels is then maybe it needs like channels, then RGB etc. Okay. Wider support. Okay, that's cool. I like it, Picasso. Serial will always be to upload and debug. WebDMX 512 needs to implement it. You can WebBustler. You need to transmit. You need to transmit a draft to the Web3 association. No, what's the name? But where's the Internet Explorer? His bitluni died again. Yeah, he did. I'll just set him up a web serial. That just be web serial. DMX is just RS485 serial. Wait, can we put... I think a DMX connector would fit on this board. The only thing that's missing is putting like a Nixie tube on that, or something like that. A transistor with tubes. Okay, peeps, enough dreaming for today. Let's add this. What is? I need to check that. Is it like a drum pad or launch pad or? Oh yeah, all right. By Pico to DM. I tried and failed. Oh, there are simple chips. I have a project box with DMX stuff. There is a simple chip that you can just use as an interface for this RS. That is already long figured out. Simple. The problem is, I think it's plus minus or 12 volts or high voltage. But I know that DMX was just a simple board that you would need to attach, and we already used it here. I think I used it with, we had like one stream. Let me check that. Bitluni Live DMX. Let me check that. DMX. Because we did this. Oh no. Why did it find? It only found this video from the old lab. We voted for a one-day project. No, that's that 6 VGA stuff. What did we do? Oh, that was an oscilloscope. Yeah, I remember that. That was funny. We just used the ESP module without a PCB and just saw that on wires. And it worked. I still have that. And it showed like on VGA, it transferred, I think, over Wi-Fi the signal and was displaying it on VGA or something. But where's the DMX? I know we did something with DMX before. Yeah, I forgot about it. If I see the project box web bastler, I will bring it here, and then I can show it. I can get you the parts that was used for that, because that was quite simple. I had some connectors for that. You check if the connectors are here, but I think they are too big. They have a box. I know that was like a simple module that you could buy for like $1 or something on AliExpress. The rapper DMX. Yeah, I like DMX. The rapper, and he's a producer. I mean, he produced Eminem. I listened to his album when I was in military. What was it at around 2000? Anyways, Pips, I love it. New project takes shape. I have new distraction, novelty factor again. Damn it. We need to make this to be able to make this on that. This will be the project after this one. Somehow I think I have one button stuck or something. Multi-factor distractions activated. Yeah, ADHD, full-fledged ADHD. Yeah, we will program this next time. I promise. I will put the title of the stream. Supercluster for real. Perfect ADHD mode, yes. I hope, okay, let me check if I get, I went full down the rabbit hole on MIDI stuff. Okay, I have maybe 10 more minutes. I can tell you a little bit, a nice coincidence that happened, because now let me see if they still didn't ship. Damn it. The guy didn't ship it. Got his money. Okay, 7 minutes. Okay, I ordered, I bought it, but it didn't ship yet, and I hope the dude ships it. So, oh damn it, I hope I don't dox it. $90, NetMD Type R, mini disc. I have mini disc, I have a mini disc player, but I don't have a NetMD. And there is, and I wanted to make also an M.2 mini disc drive. The form factor, barely fits. I think mini disc is as wide as this, but the players are also quite narrow, so they're not that big. And I thought, okay, I can use NetMD to store audio data, like store data as audio data on the mini discs, and then restore it, like read it back. Yeah, wait. Yeah, okay, no, not like that. NetMD is basically USB, and there is a web implementation for NetMD that works. But what I didn't know when I bought this device, that NetMD doesn't support reading back data. You can send data, like audio data, but you can only like read back the titles. The titles are limited. You can have only 254 tracks, and the title length is also limited. So you can store like data as titles on the mini discs. You have WebBuzzler, you have HiMD? Really? Okay. This is like a super limitation, and this was because Sony was worrying about DRMs. They didn't want you to read back commercial mini discs that have existed at that time, apparently, but everyone just used it to record from radio, like I did, and just use it like a smaller version of a Walkman or or a disc player. Disc players were always too big; they didn't fit a pocket, and mini disc players did. That's why I had one, and you could record like digitally. It wasn't like lossless because you had like the 8-track compression. Anyways, what I found out is that there is something, anyway, homebrew. Homebrew mode. Okay, so apparently some hackers managed to reverse engineer firmware of some of the Sony mini disc players and get additional functionality in there. There are type S and type R devices where, okay, can we open the toolbox? You can, for example, you can copy the whole disk, and you can write and read like faster than single speed. So you can actually write fast and read fast. I don't know how you can download like the file system and so on. And there are, wait, where is the supported device? Wait, here. Type R devices will rip at roughly half of real time. For SP, type S will rip roughly 4 times. Okay, type S is faster, but fortunately I bought one of the devices that support like here that I think I got, which one is it? 520 type S exploits. So basically I can rip MDs of that in some way or form. And I'm really looking forward to find out if that works, if I can actually read back digital data that I will be able to upload first. So not music, but actually data. And I talked like to ChatGPT for some time to find out if it should, yeah. And it was like adamant about it that it's not possible to read back, or it even answered directly that it can't be used as a randomly access data storage device. But it also indicated that there are ways of like homebrew stuff and so on, but it didn't know exactly what the details about that. So that's how I went down the rabbit hole and found out that there is some sort of firmware that we can use to access it actually. NH600D even supports data storage on normal MDs. Yeah, but they're so expensive. How much did you pay for that? I checked them. Oh, you can buy this. Oh, you can wait. $100. Oh no, that's the initial bidding. Yeah, $250 or something. D, yeah. Yeah, that's the initial starting price for those devices here. Or you can buy it for $250. So no way. Do you need a different media, or do they support like basic MD discs? Needs high MD device discs. Fenois. They also accept MD data. Oh. And the data is like... Oh, interesting. All right, so that's it. That was my rabbit hole for this week. Going down the rabbit hole of old school but really cool storage devices, analog and digital. If the dude doesn't ship the device, I might even try to snipe one of the high MD devices. Ah, right. Cool. Maybe I can learn something from Web Bastler. Antique? It's also tech from my youth, and I don't feel that old. Okay, I feel old. I use it at around 2000 still, like my mini disc player. And then I switched, I think, like early 2000, I switched instantly to MP3 players. But they were clunky and small sized. Rockbox. Okay, let me check that. What is SanDisk Sansa clip? What is Rockbox? Oh, yeah, but this is a hardware device, is it? Yeah, no. I would don't do recompression. I think NetMD you can compress beforehand before you upload the actually compressed data. So there is no transcoding on the device going on. Ah, okay. That's yeah, okay. But that's like already new tech. I mean, that's like an iPod for music lossless and lossy. Yeah. Okay, peeps. Don't snipe away all the nice devices now. I see you on Wednesday. Good night, everyone. I hope it was somewhat enjoyable. And I liked that you helped me with the PCB, with the new one, so I don't have to reorder with mistakes. Off to eBay. Good night, all. Yeah.